Hello Algebra, today we're going to be doing 11.1 notes, which is rewriting radical expressions. So let's start off with just squaring integers. This should be all review. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then we have 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So that's just all review. So the rest of this is also going to be a review. This is just a reminder of simplifying square roots. So square root of 9, that equals 3. So my answer is just 3. Square root of 1, that equals 1. So that's my answer. Square root of 36 is 6. Now, if I have two different things going on here, like I have a number or a fraction in front of my square root, I'm just going to ignore that and look at that later. I know that the square root of 100 is 10 because 10 squared is 100. So now I'm able to take negative 1/2 times 10, which will give me negative 5. And then I'm going to do the same idea over here. I'm going to look at my square root first. The square root of 64 equals 8. Then I can look at my integer in front, and 3 times 8 is 24. So all of what we just did, that should just be review. Now we're going to talk about how we can simplify expressions that may not be perfect squares. So your first step is when you look at the number, you want to see what is the greatest perfect square that gets multiplied inside of it. So if I have square root of 12, yes, I can divide 12 by 6 and 2 and 12 and 1, but neither of those are perfect squares. But I know that square root of 4 times square root of 3 gives me the square root of 12, but the square root of 4, that's a perfect square. That's how I'm able to get 2 square root of 3 equals square root of 12. You're breaking it up into a perfect square and a non-perfect square. Then you are able to take the square root of that perfect square. That's how we're kind of simplifying it. It's the same idea as if I could say 9 over 6. I'm able to break that up into 6 over 6 plus 3 over 6, and that would give me 1.5. It's kind of the same idea. We're simplifying it. So square root of 27. The greatest square root that gets multiplied into 27 is the square root of 9 times the square root of 3. Those equal the square root of 27. The square root of 9 is just 3, and then I still have my square root 3, so I write it like that. You put the number first. Same idea, square root of 48, that can be broken up into the square root of 16 times the square root of 3. There's many different ways that you can break up some of these numbers, like I could do 12 and 4, 24 and 2. But remember, the goal is you want to get the greatest perfect square as a factor. The square root of 16 is 4, and then I still have my square root of 3, so my answer is 4 root 3. Okay, go ahead and try this one on your own. You can pause it. Okay, so remember, look at the square root first. Just ignore the number in front for now. The square root of 75 can be broken into the square root of 25 times the square root of 3. The square root of 25 equals 5. And then I still have my root 3, but now I'm able to look at that number in front, which I have a 2. So all I have to do is just bring that straight down, and I have 2 times 5 times root 3. Now I can multiply 2 times 5 to give me 10, but I can't multiply that by the root 3. I'm just going to have to leave it like that. Think of it as they're not like terms. All right, square root of 56, that can be broken into square root of 4 times square root of 14. A lot of this is just looking at the factors of these numbers and trying to divide them by perfect squares. That is honestly the best way to go through it. The square root of 4 equals 2, and then I still have my square root 14. For 200, again, you can try this on your own. Pause it. Okay. I can break that up into square root of 100 times the square root of 2. The square root of 100 gives me 10, and I can't take the square root of 2, so I leave it like that. The whole idea of this is you're breaking it up into two factors. One of them has to be a perfect square. That's how you're simplifying it. Again, just look at the square root, ignore the number in front for now. The square root of 72 can be broken into the square root of 36 times the square root of 2. I know that the square root of 36 is 6, and then I still have my square root of 2, but now I'm able to bring that 5 down. So I have 5 times 6 times square root of 2. I can only multiply those numbers. You can't multiply by the square root. Think of it as you can't do x times y because it's just xy. 5 times 6 is 30, and then I still have my leftover square root of 2, and I leave it like that. All right, same idea. Just look at the number under the square root first. Square root of 18 can be broken up into the square root of 9 times the square root of 2. The square root of 9 squared, you know what I mean. Square root of 9 is 3, and then I still have my leftover 2, square root of 2, and now I want to bring down this fraction that's in front. And remember, you can only multiply the numbers by themselves. You can't multiply a number times a number being square rooted. 1/3 times 3 is 1. So I have 1 square root of 2, or just the square root of 2. All right, so that is how you handle numbers that are under a square root and need to be simplified. Now we're going to talk about variables. Very similar idea, except instead of taking the square root with the variable, you're just dividing. So the square root of a, that is just the square root of a. That can't be simplified. That's as simple as it can get. The square root of a squared, just think of that as what is 2 divided by 2. That's 1. So that just gives me 1a. The square root of 3, I can break this up the same way we want to break it up, our numbers, into a perfect square and a non-perfect square. We want to break up our radicals with variables with an even amount and a non-even amount. That means I could have square root of a squared times square root of a, and that's what gives me a cubed. Same thing with a to the 5th. Square root of a to the power of 4 times square root of a to the power of 1. For a to the root of 7, same thing, you're breaking it up. A to the square root of 6 times a to the square root of 1. So if it's an odd number, you're going to have to break it apart. The same way if I have 32, that's a non-perfect square, I have to break it up into the square root of 16 and the square root of 2. One's a perfect square, the other is not. It's very similar to if I have the square root of a to the 5th, that has to be broken up into an even amount and a non-even amount, the greatest even number you can get. So I would have a to the power of 4 times the square root of a, or the square root of a to the power of 4 times the square root of a. That's how we're breaking it up the same way. And then now the square root of a variable, remember that's just the same thing as dividing it by 2. A to the power of 4 divided by 2 will just give me a squared, and then I still have my square root of a. Those are the similarities between these. The only difference is rather than doing the square root with the numbers, you're dividing by 2 for the variables. Same idea how if I have the square root of 36, all I have to do is I know 6 times 6 gives me 36, so my answer is 6. Same way if I have a to the power of 4, that's an even number. I don't need to break it up. 4 divided by 2, is 2, so then my answer is a to the power of 2. If you have an even number as your exponent with the variable, you don't have to break it up. If it's odd, you do have to break it up into the greatest even number times the odd number. So if I know that a to the power of 2 squared is a, then that means I have a here, and I still have my square root of a attached. All right, the square root of a to the power of 4, remember I'm just dividing. 4 divided by 2 is 2, so my answer is a to the power of 2. My a to the power of 5, I broke it up into the greatest even amount, which is a to the power of 4, and left over I have a to the power of 1. Now I'm going to look at this part right here. The square root of a to the power of 4, remember you're just dividing that exponent by 2, so I get a squared, and then I still have my leftover a. A to the power of 6, remember you're just dividing that number by 2, it's even. 6 divided by 2 is 3, so that means my answer is a to the power of 3. Now I'm back at an odd number. Remember the odd number, that's when you have to break it apart. A to the square root of 6, or no, a to the power of 6, that is being square rooted, the same thing that we just did right here. Even numbers and the exponent divide by 2. That gives me a to the power of 3 and my leftover square root of a. All right, now we're going to do a few examples before my Apple Pencil dies. So, variable, remember, break it up into the greatest even number you can have. That is 16. That means if I have x to the power of 16 times x to the power of 1, I can break up that x to the power of 16. Remember, you're just dividing by 2. And that gives me x to the power of 8 with the square root of x. This is my final answer. The square root of x to the power of 1 and the square root of x is the exact same thing. Same idea over here. Break it up into the greatest even number you can have, which will give me square root of k to the power of 52 times square root of k to the power of 1. Now I want to divide that even exponent by 2, and I'll get square root of k to the power of 26 times square root of k. Oh, sorry. Ignore that part. All right, now what happens if I have both a number and a variable? Just break it up into the number part first. So I have my square root of 18 times then your variable. The square root of 18 can be broken up into the greatest perfect square, which is square root of 9 times square root of 2. Square root of 9 is just 3, and then left over, I have square root of 2. So that is the square root of 18. We got that done. Now I have to do my square root of s to the power of 4. My exponent is even, so all I have to do is divide it by 2, and I get s to the power of 2. Now the way you write this is you put the number or variable that is not under the square root first. So I would have 3s squared, you put that first, then the part that is under the square root will go next. So square root of 2. This is how you would write it, just like this. That's your final answer. You break it apart until the number and the variable, then you put it back together at the end. Same idea over here. Whoops. I have square root of 100, which is 10. Then I have the square root of m to the power of 3. Since my variable is odd, I have to break it up. Or not variable. Since my exponent is odd, I have to break it up into the greatest even amount and the odd amount, which is the square root of m squared times the square root of m. The square root of m squared, just divide the exponent by 2. That gives me m, and then I have my leftover square root of m. So we're done with the square roots. Now we have to write our answer all together. The number slash variable that is not under the square root goes first. So I have 10m. Then you can lastly write whatever is under your square root after, to the square root of m. This is your answer. Okay. Go ahead and give these a try, and then pause this, and then we'll go over it. Okay. First step, break it up into the number and the variable. Square root of 45, square root of p to the power of 2. All right, 45 can be broken up into the square root of, give me 1 second. Okay, that was a brain fart moment. Square root of 9 times square root of 5, that's the greatest number, that's the greatest square root that multiplies into 45. The square root of 9 is 3, then I have 3 root 5 as my answer. Square root of p to the power of 2, it's an even exponent, so I just divide it by 2, so I get p. The number slash variable that is not under the radical will go first, so that is 3p. Then whatever is under the radical goes after, so now root 5. Next one, same idea, we're going to break it up. I have the square root of 16, which will give me 4. Now what happens if you have two different variables, like you have one letter and a different letter? You want to break those up the same way as well. So I want to write u to the power of 4. It's an even exponent, so I'm going to divide it by 2 and get u squared. Then I have the square root of z to the power of 3. That is an odd exponent, so I have to break it up into one even, one odd, which will give me the square root of z squared times the square root of z. And I know the square root of z squared will give me just z, because I'm dividing that exponent. 2 divided by 2 gives me 1. Then left over, I get z. So now same thing, you write all of the numbers slash variables that are not under the square root first, which is going to be 4 u squared z. Then after that, you write what is under the square root after. So square root of z. Next one, not only do we have a number and a variable underneath our square root, we also have a number in front. And this number right here, we're going to totally ignore that until the very end. That's our very last step. I'm going to start by breaking up my square root into the square root of 72, and this can be broken up into the square root of 36 times the square root of 2. I know the square root of 36 is 6, so my answer for that is 6 root 2. Now I can look at my variable. The square root of a to the power of 2, my exponent is even, so I'm just going to divide by 2, and I will get the square root of a squared is a. So now I want to take my numbers slash variables that are not under the square root first. So I have 6a, then I can look at what is under the square root next, which is the square root of 2. Now normally we would be done, but we do have that 6 that's directly in front. So really all you have to do is just do 6 times everything. This 6 is times this. It cannot change this at all. Think of it as they're not same terms. So 6 times 6 is 36. Then my final answer is 36a square root of 2. Next one, same thing. Ignore the number in front for now. Break up the radical. The square root of 150 can be broken up into the square root of 25 times the square root of 6. The square root of 25 is 5, so I would write the square root of 150 as 5 square root of 6. Now I'm going to look at my variable. The square root of n to the power of 7, that is not an even exponent, so I have to break it up into the greatest even amount and the odd amount. that would be written as the square root of n to the power of 6 times the square root of n. The square root of n to the power of 6, since that's an even exponent, I'm just going to divide it by 3 and get n to the power of 3 square root of n as my answer for the square root of n to the power of 7. Same thing, write your numbers / variables on the outside of the square root first. So now I have 5n to the power of 3. Then you can write what's under the square root next. Sorry, I highlighted the wrong thing. So then on the inside, I have 6n. You would write it just like this. In general, you want to put the number before the variable, whether it be under the square root or outside of the square root. Obviously, you can't switch those, but if there is both, out of the square root, number first, both inside the square root, number first. All right, super fast review to remind you. A to the power of 3, square root of a to the power of 3, that has to be broken up into the square root of a to the power of 2 times the square root of a. This is my even number. This is what is no longer going to be under the square root. Divide your exponent by 2 and you'll get 1. So a to the power of 1, square root of a. If I have x to the power of 7, same thing, that's an odd amount. I want to break it up into the greatest even amount. So x to the power of 6 times x. Obviously, they're both being square rooted. This is my even amount. This is what is going to be divided by 2. 6 divided by 2 is 3, so my exponent will become 3, and I still have the square root of x. If I have 16 x to the power of 5, all under the square root, you want to break it up into the variables and the numbers. I have a square root of 16, square root of x to the power of 5. The square root of 16 will become 4. If I have an odd number as my exponent for a variable, that's when you have to break it up into 2. The greatest even amount, which is x to the power of 4, and the odd amount, which is x. Since I have an even exponent, I can divide it by 2, so I get x to the power of 2, square root of x. You write your numbers not under, or your number / variable not under it first, 4x squared. Then whatever that is under the radical goes after, square root of x.